Now I'm just sitting here editing this video and a thought's occurred to me. Especially with a small cell like that, I've got to stop putting them into short circuit and just put a reasonable load on them. It's got to be detrimental to the cell. So it's just a thought I had, you know. I have to give myself a slap on the wrist. Just another thought. Right, well, I've been having a bit of a go. As you can see, a new tidy bench. Meters on the ready. Some things to play with. That's the one you've already seen. That's my little motor. Nice tidy bench. Got all this space now, all covered. This nice cardboard. A couple of new developments there. They'll come along tonight. My switch has arrived. So we've got 0.1 ohms, 0.2, half an ohm, 1 ohm, 2 ohms and 3 ohms. Those will be the loads that I'm going to be switching. I'll build that tomorrow now. Won't do it tonight. Oh yeah, those. You know what I'm like when I buy these things from the shop and try them and make batteries out of it. You've seen the old Head and Shoulders and what have you. I'll do those tomorrow as well. Just something that was bought in the shops again. That I know actually works. So, and over here, I've had a bit of tidy up on the other bench as well. I got my new ultrasonic cleaner. You know what that is? The blender, baby's bottle warmer, my light, coffee grinder. You know what that is? That is a ceramic sort of a hot plate from a cooker. I intend to put that into action. This is a motor speed controller, but it's a 2 kilowatt job from China, so it's probably one. So I'm going to connect that to that, so I can control the temperature on that. Not sure what I'm going to do with that yet. Oh yeah, this is some more of that. Basically, that's my extractor fan. I just need to extend that pipe, tube, whatever you want to call it. So that's that. Got my scales there and some pots. Look, the hot plate. That, interestingly enough, is I dug it out today. Well, tonight actually. It's an old solder pot. You melt solder in there, but that goes up to a 450 degrees. Now I have used that. I used it a couple of weeks back, tried some hydrothermal carbonisation, and what I did was I put kind of a lid on it like that with some weight. And what happened was that I need something better than that. Obviously, you've got to work something out, but you know, you've got your temperatures. Brilliant. Now it says 200, but it's not 200, and that probably isn't 450, but I can measure the temperatures, that's not a problem. So yeah, what happened was with that, every so often it would let some steam out. So it was kind of a pressure relief valve, if you like, so that could come in handy at the moment. So yeah, that corner there, I'm going to attack that tomorrow, and that corner there, I'm going to attack that tomorrow as well. Just didn't have the heart to do it tonight, but you know, I think I've done enough. Look at this, hey? Robert Murray Smith, eat your heart out. There's a new kid in town. Just kidding, Bob. Just kidding. Yeah, and that, I forgot that was there. bloodthirsty work, these videos. So yeah, I can get a lot more done now. Got some space. These I did test earlier on. That's like an offshoot of that, if you like, the one you've seen. They're just basically 1 centimetre cells again, literally 1 centimetre. As I say, that one I'm going to fire up as well. So yeah, there's a lot going on, so I'll keep you posted. Of that is my trusty old all-terrain tripod for the camera phone. Yeah, that's when I was working all the hours out for that battery that was in short for 150 hours. So there you go, it's all happening, isn't it? Speak to you soon. Just giving that one a quick flip. Don't know what the voltage is. Let's have a look. The voltage is 2.4, which is rising slightly, I think. Yep, it's rising. 2.43. See if he's got enough current to drive this. I haven't tested this one yet, it's the first time, so okay, whizzing the motor around, so that's a good start. Where are we? Short circuit. That copper strip, I do not trust that. I'm going to have to put some pressure on that, I think. Right, let's just try a short circuit. Forget those resistors, put a bit of pressure on that copper. That copper is connecting to that carbon there, so okay, 57 milliamps. Right, so I've got a connection now. It is that copper strip. So again, that's on a dead short, and that's rising, so this is the first time I've actually tried this one. So again, the current's rising before it falls. Now this is a dead short, so seems to be slowing now. Yeah, definitely slowing down. But I mean, okay, it's dropping now, but that is good solid current there. Amazing. Now again, that's a solid state cell, no separator. That's carbon, that's magnesium. That's my copper connection strip to the meter for the dead short. So that's that one. Don't know what to make of it yet, but I just wanted to try this other carbon, really. That's all that was about. So it should still have plenty in it to drive that motor. Yeah, look at that whizzing round. So I'm guessing I should put the timer on that one at some stage. Won't do it now, but timer on it and see how that one goes. I'll do that tomorrow. These, don't know yet, don't know what to say. That one, which you've already seen, they've sat there now for 2 days. Yeah, it's Friday night. I think it was Wednesday night. Yeah, Friday. Yeah, it's 2 days. Not a clue if there's going to be any voltage in it, but and there is. 1.2 volts. Yeah, that's what you get for moving stuff, you see. That one's okay. That one's okay. Oh, that's odd, isn't it? I'm sure that motor span in the other direction then. Yeah, it did. So actually, oh no, that's right. The carbon is the cathode, so that should spin in the same direction. Yeah, that's right. Okay, carbon, magnesium, yeah. Right, well, I'm going to go away and have a play, and I'll be back soon. This is the first one of those that you just saw on the bench. This is the carbon. I've put my spongy activated carbon, got a separator, and this is actually zinc. So a little squirt of my electrolyte on there. Try the voltage first. Not expecting anything great because it is zinc after all. Yeah, 1 volt and rising, so okay, that's a good sign. Try the motor. Okay, it's spinning the motor. Didn't sound as though it was whizzing around too quickly. I have to sort a connection out on these. That's next to useless, but I'll put some pressure on it. Where's my short circuit lead? There it is. Okay, so there's the current. This is zinc. 3, 2, 1. Okay, 130 odd milliamps. That's strange. That one's. I'm going to put some squared pressure on that. That's better, you see. I do know that I'm struggling to get a connection on that copper. Definitely struggling with that. So try that. Okay, that's the current. Not mind blowing. I'm trying to give it a squirt of something else. Okay, no real difference. Okay, I'm just having a play basically. I wanted to do the 2 carbon test again, so I think what I'll probably do is put a smear just a light smear of my spongy carbon activated. Oops. Okay. Get that on there and try that zinc now. Oh, check the volts first, eh? Oh, 1.127 with a zinc for the current. I'll try that. Check this one out again. I don't know why, but this carbon fibre weave always works better. I don't know why. There are some properties in it that just, I don't know what they are. I mean, the resistance for one is quite high, so you know, that's graphite. So that's magnesium. You can see what happened then. Current wise, straight up to 1 amp. So put the zinc back on. Oh, 400 milliamps now. Times when you just can't believe your luck. I can't believe mine at the moment. I actually bought a sonicator from China, from eBay, and it didn't work. So after about 2 months later, I get my new one, which you've already seen, which is there. And I decided last night to use it in anger, making that with that and that and one of these. That's what's left of it. So after all that, you end up with that, and then you take this and you put it in one of these. Now, temperature I don't need. The ultrasonic side of it I do, and nothing happens. I don't know what I've got to do. I mean, everything else works. The heater works, the timer works there, but the machine's busted again. Oh, so here we go. I mean, you know, what can I say? I just cannot believe my luck with this one. But I've messaged them, and I mean the heat is bubbling away, I can hear that. But no sonification, nothing. Back to the drawing board, I suppose, isn't it? Just get back to making batteries the old-fashioned way at the moment. Talking about this stuff, it is called anodic oxidization, as in your anode oxidizing. These magnesium batteries are a real challenge. Yeah, the whole thing is a real challenge. I think I found a new way around this, with an addition to the electrolyte. I found that I mean, that has sat, it's dry now, but that sat there all night, and it did not end up like that. So I think I've cracked that bit. And to be fair, it is just an addition to the electrolyte. It's not what was I doing? Oh yeah, putting a hydroxide coating on. But to be fair, even that works. And that's a piece that has been in service and has got the hydroxide coating on, but even that is not as good as that. So seem to be getting there with that one. But well, I'm just off to the shops now to get some what was it, silicon crystal, silicon carbide crystal. So for my local crystal shop, hopefully. That's about it for today. And oh yeah, I'm going to the beach to get some seaweed. Speak to you soon. Did a video earlier on. Bit despondent last night because of the sonicator, but life has its ups and downs. One of the downs at the moment is this stuff. You can only buy a 9% solution. Best on eBay is 12%. But I've popped that in the freezer, and we've got ice, and we've got what should be a better percentage there of hydrogen peroxide. I don't know what it's going to be. Could be 30%, 20%, don't really know, but it's going to be better than that. So that's that. So yeah, despondency and ups and downs and all that. Well, I must admit, last night I was despondent, so I had a few beers and obviously looked at some videos on YouTube and looked at Robert Murray Smith's remake on how to make graphene quickly, which I tried to do yesterday with a sonicator that doesn't work. So that was that. But I started looking at the comments on this new video. Oh, I was in stitches, I must admit. My sides were bursting, you know. I was just laughing that much. Some of these comments, and I couldn't help commenting myself on some of the comments. This one guy asked Robert a question. Well, it was a whole series of questions really, and I looked at Robert's comment and it said, "I don't know," and I could just see him laughing. You know, I could just see him sitting there laughing like. And I just had to put, "I don't know either," because I didn't. Oh, crazy comments. I mean, it just, one of those things. So it lightened up the evening a bit. I spoke earlier on about this, obviously with the magnesium, untreated, no good at all. this black stuff, I mean that one, it's physically attacked the magnesium. This one, it's got what's it called? I did call it what it was earlier on. Oh yeah, anodic oxidization, which is oxidization of the anode. So that's that. That's a piece, as I said earlier, that was treated with hydroxide, as in Sylar method, and that one was another additive that I've put in the electrolyte, so that's that one. Yeah, so ups and downs. I've been out today and got myself a whole bag of this stuff, seaweed. Now, not certain if I've got the right variety, but I've got two varieties in here. The problem was the tide was in, so I was limited to what I could do. So I'm going to get back down to the beach tomorrow, find out first when high tide is and all the rest of it, and get there early and get some others. So that's that. What I'm going to do is split that bag into thirds. I think 1/3 will be for hydrothermal carbonisation for obvious reasons. The other third will be for other stuff not really associated with batteries, and the other third I'm gonna stop it from stinking first, but I shall be looking at its properties possibly within batteries. I'm going to be doing that tonight actually in about an hour's time, but properties within batteries as it is, to see if there are any properties. So that's that as well. Also, I've been out today and I'd already got this. Okay, I'd already got that because I'm having a play with it. No point in saying what yet, but do you know what? Google it. So I also went out. Now that's man-made, that powder. It's grey. I mean, normally it's green, but that's grey, so I don't know. But I went out and got this little baby, which is a crystallized version of that. Silicon carbide crystals then. Now again, no point in me saying what I'm about to do or try with it. Just Google it. Go on Wikipedia. You'll soon get the gist of where I'm coming from with that, if you do that. Now the other one I went out and got, I've been to the crystal shop, was that tourmaline. Now this particular one is black. I couldn't get the one I wanted. I've had to order it from the crystal shop. The one I wanted was sort of a brownish yellow. Now if you were to Google that and look at the properties of that as well, you'll see where I'm coming from, especially with the makeup of it. And if you look at the numbers, its chemical composition and all the rest of it, if that's the right word, chemical composition, not certain if it is, but I'm not a chemist, am I? Yeah, so tourmaline, two very interesting items there. So yeah, going to be a lot going on. Things might go a bit quiet in the next week with me because I've got such a lot to do. I've mentioned before that I'm trying to design a circuit as well, to run kind of a setup where it's all self-sustaining based on crystal cell batteries that regenerate. Now the eventual idea I've got with my cells is that I'll make a cell. Industrial format, flat, not very thick, whatever the voltage is going to be. And let's say that that cell was 5 amp hours. Yeah. And that cell would deliver, if it would deliver half of its current continuously, that'd be great, but I don't think that's going to happen. But let's say a third, or even a quarter of its current continuously in a loop. So it gives the power and regenerates at the same time. That's the ideal scenario. I've said that before. But this little circuit I'm developing is, I'll do this in block diagram, is a chip called a 4017, which is a 10 output, I was corrected on this by Martin, I think, decade counter. I called it a binary counter. So it's got 10 outputs. Now, each of these outputs, you can do whatever you like with them. You can switch a transistor. Now, what I intend to do on each one of these outputs is switch the battery into a load. Now, whatever load, that could be a LED, you know, so that's that. So each of these outputs will do that. Oops. Now the chip is controlled by clock pulses, normally with a 555 timer, but I'm not going to use a 555. I'm going to use like a flip-flop circuit, couple of transistors, capacitors, resistors. Won't draw a lot of current. The whole thing, I mean, the quiescent current on the chip, I can't remember what it is, but it's not a lot. So the whole thing in itself should not draw a lot of current. So I'm not using the output directly to switch. I'm just going to be switching a transistor. Can be anything, NPN, PNP, could be a MOSFET, whatever. Haven't decided yet. What I'm going to do initially is use AA cells there, and then obviously replace those eventually with my cells. Now if I'm lighting up an LED, I'm going to need 3 volts at least, with a very low VF there, and hopefully we'll have enough voltage to switch an LED. But it doesn't have to be an LED, it can be anything, it doesn't matter what it is. It could be something like these motors that don't rely on the voltage. So that's the output side of it. So 10 outputs. Now what the idea is, well, let's say that's number 1, output number 1. You draw, let's say, 30 milliamps. Now you could use that transistor to draw, to switch something else, a much higher load. You could switch a relay with it, whatever, you know, that's all by the by. But number 1 output. Now you need a capacitor for your timing to switch between the outputs. So you could set the time from 1 hertz to 20 kilohertz. It's up to you, but obviously I would switch slower than that. So you draw your current from the cell, which is one of my cells, and then it switches to output 2. The same load, same setup, another transistor into the same load. So I would be switching another cell from output 2, and so on to 3, 4, 5, 6, 7. You can use the 10, or you could use 5. Makes no difference. But obviously, by the time it gets, let's say, to 10, output 1 has regenerated, so it switches back to 1, and it's a continual loop. So all of these cells have got time to regenerate. Now if you ask me why I'm doing this, it's because I want to, and that's it, and because I can, because I know the chip, I've been using it for years. I mean, there's loads of other chips around. You know, you could use a PIC processor, you could use just about anything, But the interesting bit is on the input side. This chip to operate needs 3 volts. So I would have to put 2 cells together to get my 3 volts. Now what I'm going to do, what I'm hoping to do, is to have 2 lots of these. And again, these alternate. And again, that could be done with a basic flip-flop circuit, or whatever means I choose. Haven't decided, but it's probably going to be a flip-flop, and it swaps alternately between those 2 cells on the input to supply the chip with 3 volts. Now, with a capacitor as well on the input, as these switch over, the capacitor should hold enough current to keep the chip going, and it's just perpetual. The whole thing is just perpetual, regenerating cells. So these regenerate, those have got time to regenerate, so the whole thing becomes perpetual. That's my little dream, if you like, and I'm working on that. So again, you know, a lot to do. Don't know where I'm going to find the time to do it all, but be like Robert Murray Smith, I suppose. I'd be up at 3 in the morning, which I think if you watch my videos, you know I am anyway. Even Christmas morning. So yeah, that's that. A few ups and a few downs, and some new goodies to play with, and some seaweed. So what I'm going to do is have a little play and build some batteries. Those 2, because I moved them and all the rest of it, didn't work at all. We know all about that one. We know about that one. So yeah, that one's fallen apart. Lovely. But you know, I'll put it back together in a minute, put a clamp on it, and get it going again. So that's that. Yeah, so there you go. That's it. Okay, there you go. No electrolyte, none of that, just carbon and magnesium. Same with that, carbon fibre weave, magnesium, carbon, magnesium. So there you go. I'm pointing at that, you can't see it. There it is. Okay. One of the other reasons I was a bit despondent last night was because obviously I couldn't do anything with that. All I've got is salty graphite. The salt isn't a problem, it can stay where it is. But I'd also got 2 of the lots of activated carbon to do as well, and there they are. Now that one is a bit different to that to look at, because you can probably see floating on the top there this nice silvery grey matter. Well, I think I know what that is. Didn't do that very well. You can actually scoop it off if you're careful, and I'm not being careful at the moment, so I have scooped it off before, but I wanted to sonicate that as well and see what we ended up with. But hey ho, it's just one of those things, isn't it? But I suppose I'll have to send this one back as well. Nightmare. Okay. It's not chopped up very fine. It's quite difficult because of its cellular structure, I suppose, to chop up. That's a bit of seaweed there chopped up. I'm just making an alternative seaweed battery look, or well, trying to. Carbon fibre weave, no activated carbon, So there's the seaweed. There's a piece of magnesium. Now, I haven't tested this, I promise you that, but my guess is now we're going to get voltage from that, because you get voltage from just about anything really. I'll find my probes and turn that on as well. I think we won't be too ambitious with this one. I'll put it on the 20 milliamp scale. So can you see the volts? Yes, you can. See the current. Okay, we're going to have volts for obvious reasons. That stuff's just come out of the sea. Okay, 1.9 volts. That's amazing, isn't it? A little bit of seaweed, look. The ultimate test, I suppose, will it actually run the motor? Now I'll be amazed if this runs. I will be amazed. So let's get a bit of pressure on the weave. Pressure on there. Wow. Seaweed battery. That's amazing. Now, you know me. You know what I'm like. My current tests, it's just going to have to be, isn't it? I just want to clean this up. Because obviously for current, we need good contact on the weave. So that's that bit. Where's the other one now? Oh yeah. Okay. What are we gonna get here? Some pressure on the cell. Oh, okay. 200 milliamp scale then. That is unbelievable. And that is just seaweed straight out the blender. Nothing else, that's it. That is amazing. So, I'm guessing hydrothermal carbonisation next. Because I would like to attempt what RMS did with his little solid state thingy with his seaweed. Because I know what the properties are, so I know how it worked basically. So yeah, but I want to try it on the weave. Obviously, you know, I don't want to put it on a piece of graphite. I want to try it on this carbon fibre weave. So I'll get some on the brew and take it from there. But first things first, by no means have I finished playing with this just yet. I'm going to have another little play. I've swapped the piece of magnesium, whatever I've done with that. No, what have I done with that? Well, wherever it is where it is. Oh, there it is. Okay, I've swapped the magnesium for zinc. Just going to try the voltage. .8. Pressure on the cell. 0.8. Current. Uh, 31 milliamps, I think that was, wasn't it? 30, yeah, 30 odd milliamps. So not as good as the magnesium. Now, for obvious reasons, you've got sea salt, haven't you, and magnesium. So what I'll do is try and boost the electrolyte a little bit. Back in a minute. Yeah, first of all, I've just boosted the electrolyte with a bit of magnesium chloride. So that's that bit. Just wanted to try that first. Not going to bother with volts. Current. Okay. Not a good connection again, but okay, milliamps is still good. Now, if I put the zinc back on there, yeah, nice and clean. Still hovering around the 30 milliamps. So I'll be back. A little bit of a boost on the electrolyte with the zinc plate. Let's have a little look. Yeah, 43 milliamps. Okay, so kind of on the right tracks there. Just got one other thing to try. I'll be back. I think I've just done what I wanted to do. I haven't touched the electrolyte. Let's have a look at the current. Now, I haven't tested this. You can either believe that or not. Makes no difference to me. But let's see what happens. It's either going to be good or not so good. So be good then. Now that's still zinc. Let's try the magnesium again. Okay, let's get to the 10 amp scale. Oh, an amp from SEAWEED. But of course it's not just SEAWEED, is it? Because the truth of the matter is, I've put a bit of activated carbon in there, look, with the SEAWEED. So yeah, bit of a boost, look. That zinc was amazing though. Nowhere near that current, obviously, but you know, to boost it from what it was to what it then was. With the activated carbon, yeah, you know, from like sort of 30 milliamps to a lot more. Obviously it needs a bit of work with the electrolyte layer there, because it's magnesium chloride, isn't it? So needs a bit of work, but let's try this again. Le motor. Yeah, loving it. People comment about me using activated carbon, and one or two other people, not on YouTube, have said the same thing. Why are you bothering? Right this minute, because it was a starting point. Now, all the time I've been using this, I know all about graphene. I know all about the ways that graphene can be structured. I know all about, you know, well, not all about, but I know what this stuff is, you know, graphene oxide, graphene, the uses that you can put it to, and all the rest of it. Its uses, you know, in structured layers with all this kind of stuff, you know, in batteries or whatever, you know, a bulletproof vest if you like, carbon nanotubes, and, you know, I know all about this stuff, but I want to stick with activated carbon at the moment. You know, I'm going to go on to other things, we know that, but this side of it, it's cheap, it's environmentally friendly, no two ways about that, and that's one of the key aspects of what I'm doing, is to keep it all environmentally friendly and low cost. and regenerating, self-regenerating. That's what it's all about in a nutshell. So you know, it's a challenge to work with magnesium. It really is. I mean, you know, I'm looking heavily into anodes and cathodes and structuring those at the moment. What's the word that keeps cropping up in my mind? Polyvinylidene. Yeah, that's it. Polyvinylidene. That word keeps cropping up in my mind, and you know, if you Google it, as I've said, it'll tell you all about it, where its uses are, and especially with anodes and cathodes, like I just said. So now, whether or not I can produce what I want to produce, especially with that, in my meagre little man cave, you know, it's not a lab. You know, whether I can produce what I need to produce, I don't know. But you know what? I'm going to give it a right good go. And if I can't do that, I'll find another way out of it, or around it. It's called thinking outside of the box. If you keep thinking inside that box, where everyone else is, then it ain't gonna happen, is it? I haven't got $1 million to spend on development, you see. So I'll just spend a few quid here and a few quid there and earn a living. So there you go. A bit about what I was saying. You know, I've done these. You know, it's been done. Well, by me anyway, you know, and lots of other people. RMS has cornered the market with this, but, you know, all I'm saying is, I am into all these other things as well, so I'm just not there yet with graphene, with my batteries. Yeah, a piece of graphite, you know, and whatever, but just not ready for it just yet. So that's me. I'm back again. I'm just got a load of seaweed in the blender at the moment, trying to deal with that. But I've just had a thought, which was obviously thinking about all of this with no separator, and what Robert Murray Smith said in his video about his little similar cell, that, you know, no separator. So there it is, seaweed, no separator, and I'm just about to try it. 3, 2, 1. We're on the 10 amp scale. Okay. 340 milliamps, 330 milliamps. Wow. No separator. So yeah, he was quite right about that seaweed, wasn't he? With no separator. So if I can find the magnesium, just try that. Again, magnesium, no separator. I'm expecting better things, obviously, with this, but oh, no then. That'll be a no. 400 milliamps from seaweed. Wow. And that is literally through the seaweed, you know. That's just seaweed, just, you know, chopped up, great big chunks of seaweed. So yeah, just thought I'd try that one. Happy days. I'll be back. Same thing again. I've just put some cling film on here though, because I keep messing up the surface of this hot plate thing, thermal thing it is. It can take up to like 1800 degrees or something like that, but I'm using it for this and I shouldn't be really, but Yeah, just seaweed again, and no separator. What I thought I'd do was try my electrolyte, which is there, and I have showed you this before. It's quite active. Yeah, it really is like a volcano, that stuff. But there you go. Once you get the top layer off, it's quite nice electrolyte. So I'm just going to try a little bit on this, and see what current we get. I mean, this is zinc again, so that's my electrolyte that was designed for zinc, basically. Current. Okay. Healthy above 600 milliamps there, look. Very nice. So again, seaweed, no separator. And carbon fibre weave and a bit of activated carbon, and it is a little bit of activated carbon, I must add. So yeah, happy days, eh? And you know what, doesn't get any greener than that. Pardon the pun. Okay, earlier on I think I said it's from the sea, so it's got magnesium chloride, but it's not magnesium chloride, is it, as such? Just sodium in it. Motor's running, look. Yeah, happy days, isn't it? Don't know what the voltage is, of course, because I'm not that interested in voltage these days. Yeah, 0.7, and it's climbing, so it's obviously going to go back up to the 0.8 that it would have started at. So yeah, nice green little battery, look. Eco cell. Gonna have to think of a logo. Something to do with the sea. Food for thought. 10 minutes. Just wanted to just check this like you normally do, or I do, for any signs of recovery. I think what was about 650 milliamps or something like that one. This was zinc, so no, I won't refresh the electrolyte. I'll just go in as it is. It's wet enough, so 3, 2, 1. 630 milliamps then. There's a bit of a recovery there. I think I'm not going to do too much more tonight now, because I've got battery wise, I've got 1 or 2 things that I want to do. So what I may do is just put this up on YouTube. Bit of fun, isn't it? Seaweed battery. I know it's been done before many times and all the rest of it, but I've never seen anyone actually chop seaweed up and make a battery. I mean, it may be out there, I don't know. I'm just wondering if that was seaweed electrolyte. I've been drying this a little bit, some seaweed. I've got a load more, because I've got to chop a load more up or blend it up, but just getting it ready for carbonisation, really. Don't need a lot, so there you go. Okay, I was going to go off and make a video, but a couple of things happened. I've just burned out my blender. So one little tip is, if you're going to chop seaweed up in a blender, either get an industrial one or give it a chance. If you've got a cheapy one like I have, and chop it up a bit with the scissors, like I've done there, and just give it a bit of a start, because you will burn it out. The structure of this stuff is it's so strong, but you know, that's that. if you can hear some music in the background, I apologise. I already said that before that my little man cave is next door to a bar, but that's that. Good in one way, bad in another. I've just moved that one along for a specific reason. I'm going to try the current again anyway to see what we've got. And okay, 500 milliamps, not bad. Now the other thing was, a mate of mine's been round, and I showed him that, and he said, oh yeah, well, how do I know what you've done to it? You know, you could have done anything, and you know, might not just be seaweed. And I thought, you know what, Mr. Skeptical, so I didn't bother to sort of go into details anymore with him. I couldn't be bothered. But you know, for the skeptics, because there are going to be skeptics, I know that. There's a brand new piece of carbon fibre weave, right? I'm going to cut a piece off. I'm going to put that under there. Well, actually, I'll disconnect that one now. We don't need it. I'll put that there because that's my connection for the weave, as you know. And what I'm going to do, I'm just going to take some of this seaweed. Well, actually, no, we won't. We already know that makes a battery, don't we? We know that. We've tried that. Now, what I'm going to do is just the tiniest amount, and it is a small amount, of activated carbon on there, like so. That's literally about, I don't know, 2 mil thick. I'm going to take some of that seaweed, plonk that on there like that. Right, and what I wanted to try, the one thing I wanted to try, this one is just, I've been drying it. It's kind of almost, well, it's semi-dry if you like. I could have tried some of that, but the one thing I did want to try was the seaweed, as I call it, electrolyte. So, seaweed electrolyte. Just squirt some of that on there like that. Now with that one we didn't need a separator, did we? So I just want to try that as it is, because the other one I gave it a boost, didn't I, with my electrolyte. So where are we? There. Okay, so just have a little look at that. That's bare seaweed, and yeah, that's about what we got before, I suppose. Now that was out of the blender. This is like quite big chunks, so let's put some of my electrolyte on there. Try it again. There we go, 430 milliamps, look, with my electrolyte for zinc. My electrolyte. So yeah, bit of a boost there, and straight away from 30 milliamps up to almost, well, 430 milliamps really. So yeah, there it is, seaweed battery. Kev's seaweed battery, made in 2 minutes flat. It's crazy, isn't it? This, it is crazy, but you know, it is what it is. So I mean, that's as I call it, seaweed electrolyte. I'm going to work on that, and it's obviously going to work because it's, you know, it's based on salt, isn't it? You know, the sea's got salt in it, so it will obviously work, and that's all there is to it, and that's why it works. There are some other properties in seaweed that you know, we're exploring, and I mean the separator for one. As I said before, RMS was quite right, didn't need a separator, because there are some qualities in the seaweed that make it so that you don't need the separator, and that's it. Piece of magnesium there, look. Now I'm not expecting too much from that, because A, it needs a bit of a clean, and B, the electrolyte is not geared up really for that magnesium. It's another piece of magnesium, not reporting a lot really. I've got a feeling that's going to shoot up though, as the electrolyte starts to work with the magnesium. But like I say, it's not, that electrolyte is not fully geared. The magnesium. Okay. 450 milliamps, look. I think the music's getting louder, so next door. Anyway, just thought I'd show you that for Mr. Skeptical, or any other skeptics out there. SEAWEED battery. Over and out.